This is building WebSocket applications with Grizzly and GlassFish. Everybody hear me at the back? Okay, good. It's only a small room. Okay. Thanks. Like I say, thanks for coming after the party for 2 hours of GlassFish and Grizzly. I wonder how many of you will bail before the end of the 2 hours. So I'll basically go through who am I first. Okay, so I'm basically a field consultant. So I work for a company that does middleware mainly around large-scale systems. And we do it across the board on many different vendors. So the reason I'm putting this up is basically I'm not a WebSockets specialist. I'm not a GlassFish specialist. But what I'm aware of at the moment is what our customers are looking at with WebSockets. And this sort of talk is around a very, very cut-down version of some POCs that we've done around WebSockets, mainly for gaming and finance companies, mainly just experimenting with the technologies and seeing if they work for their use cases. So that's me. So I'm not here to sell anything. I'm not here to say this is awesome. So if anyone wants to ask, while we go through this, just ask questions. That's fine. As we go along, we've got 2 hours of me talking. So the agenda we're going to do is I'm going to do a short introduction to WebSockets and push. A little look at the APIs for WebSockets in GlassFish, and this is GlassFish 3.1.2.x, whatever we're up to now. So it's one that you can download now and use in production. So it's not J7 WebSockets API, as that only came out in September, so it's a bit late for me. We're going to look through a code walkthrough on a basic Echo server, so sending a message on a WebSocket, getting it back, put it in JavaScript. And when we're doing the code, the chances of me getting this right are probably nil. So I really do need people to watch and shout out if I type something wrong, because it's going to happen. If you know what it's like in pair programming, well, this is like 10 times more. So there will be mistakes, there will be stack traces, I'm sure about it. So we'll look at a basic Echo server. Now, Echo is not very interesting because HTTP AJAX can do that. So we'll then look at expanding that. Actually, a slide slightly wrong. We look at expanding that to then push some messages down. Now, it's going to be a contrived use case we'll use. We'll just spawn a thread and start pushing data down the WebSocket to the browser and render that. But it demonstrates how that works. And then this is more getting into the use cases we've been discussing with customers. So we're going to look at how you could maybe use a data grid product. In this case, we'd be using Oracle Coherence, but no other reason than I know it. And look up how we could hook up WebSockets to a data grid through GlassFish, and then push updates that are occurring on the grid down to a browser. And hopefully we'll get to the point where we have a HTML5 canvas graph updating based on some stock prices. If we get to the end and my voice holds out, and then we'll basically have a summary. Okay. So like I say, ask questions as we go along and help me out with the code. Okay. I have no idea whether this will take 2 hours or 1 hour, or 3 hours even. So you practice, but who knows? Okay, so let's look at HTTP. This is a standard HTTP model, as you all will know. It's a request-response protocol. A browser sends a GET request to a URI for a resource. Typically, that request will have about a kilobyte of overhead on HTTP headers. And then web server goes away, finds the URI, reads it, and sends it down as a server response. Again, there's a bit of overhead on that, in that you have response headers as well, set cookie, and then the browser displays the page. So the problems with that is essentially it's a request response protocol, as we've all known for a long time. And it's half duplex, and what that means is you can only send traffic in one direction at any point in time. So you're either getting or you're receiving data. And because it's originally designed, well, it is a stateless protocol, there's a lot of redundant data on that. So, like I say, there tends to be around a kilobyte of headers, depending on what you've got. So you'll have all the headers for cookies, headers for what content types you accept, headers for just general, content length, and whether you encode zip encoding and all that, those sort of things. And they all build up. And that data is redundant in a push model because it's sent every request and it's received on every request. And it's often the case that you need a new connection. Keep alive helps a little bit, but essentially that connection can be torn down at any point. So we look a little about push. Now, push is to give, the reason people do push technology is to have a more responsive user interface. So you don't have to render the whole page for each request. So you don't do a get the whole page and render it for the user interface. You want small pieces of data to give an interactive experience. And does anyone here use different types of push? I won't say push technologies, that's a company, but push techniques. So which ones do you use? Long polling? Okay. So we look at how people do push now. This is to link in with Ajax. So you want to get updates from a server essentially in real time without having to request them, ideally. So these are the techniques that people use now. So you have regular polling. So this is, you send a request at a set interval, an HTTP request from a browser for JavaScript. That works. So you send a request. If the server hasn't got any response for you, say any event that you're interested in, then you come back with a error or whatever, depending on what protocol you've designed is. But then two events may occur between your polling interval and you send another request response, and you either get both of those or you get none of those, depending on how you've written your application. And this is quite expensive, obviously, from both a service perspective and a client perspective, in that you have to manage this polling. So the alternative is to do long polling. This is essentially where you do a HTTP request and the server hangs on to that request until there is an event, and then it sends the data back down with a response. And so essentially you're requesting thread in the browser is held up while waiting, and worst case, in early days, the server often had a thread open waiting until there was an event that it could send down to the browser. So it's quite expensive on the server, and there are obviously ways to mitigate that with asynchronous servlets and those sort of techniques, but they're all a bit of a hack at the end of the day. So this can be very resource hungry on the server, and the sort of customers we're talking about are customers that are essentially doing online gaming. So they have hundreds of thousands of users potentially connected. So these sort of techniques are very expensive for them, and bandwidth is expensive. The other option is to go into HTTP streaming. So this is where we basically open a HTTP connection or XML HTTP request, and you hold that open and get multiple responses sent down from the server. So again, the server is holding the response open and can send multiple data and never actually closes the response. again, this is expensive, both on server side and client side. And it's not very friendly to proxies, and it has a tendency for the proxy to tear these things down, and in which case you have to reconnect and go back to long polling. Okay. And then, obviously, we get Comet, which is essentially just relieving some of the pressure on the server side to allow asynchronous servlets. But it's quite complicated to develop, and it's not. I mean, this is what they do use now, but it is very expensive for them. The way a lot of these sort of gaming companies work is they tend to do a lot of syndication as well. So you get all these aggregation websites that are. When we talk about gaming, he's probably not as familiar in the US as in Europe. It's things like in-play betting on sport. So what their use case is updating odds on who's about to score or get the next point in a game, and those need to be updated in real time, or as real time as possible, because when the client comes back to place a bet or an order, then those odds may have changed and they may not do it, so they lose that order or stake. And also, it's a very complicated market, and there are many aggregators that are aggregating odds and prices from many gaming companies, and they all using reverse AJAX onto their servers to poll and pull. So their server farms are very loaded from these sort of techniques. If you think of an HTTP header is about a K in size, if you then scale that up into hundreds or thousands of concurrent connections, then that's a lot of wasted bandwidth. And these places tend to be in strange offshore locations for tax reasons, which tend to have expensive bandwidth, and the markets tend to be fairly sewn up. So the future really going forward is WebSockets. Is anyone using WebSockets? Okay. So why are you in this talk? Tutorial, sorry, yeah. So WebSockets is new to HTML5, and it's a combination of both a protocol through RFC process and a W3C spec for the JavaScript. But what WebSockets does is it gives you a full duplex connection between browser and a server. So you're basically opening a socket, and that socket, again, browser can send and server can send simultaneously over the socket. So in that case, it's better than long polling in the sense that it's just one single dedicated socket between a back-end WebSocket server and the browser. So this area, it's the reason that clients are looking at this in proof of concept is this stuff is in flux, really. No way am I telling you this is mature technology. This is not mature technology. And most of the application servers have only just started supporting WebSockets. Prior to that, you would have had to get a proprietary, well, not proprietary, but a specialist company to give you a WebSocket server. But the protocol is defined by RFC 6455. So it is now a standard, and that is ratified, or whatever the word is. And the JavaScript API is defined by W3C's WebSocket spec. So now is probably the time to experiment, but not necessarily the time to roll out into production.
What's the difference between SSE and WebSockets?
Okay, SSE sneaked onto the slide there, so I'm not talking about it anywhere else. But SSE is over HTTP, so it's still an HTTP protocol, and it's server-sent events, so it's events sent down from the server to the browser over HTTP.
Well, but how's it different? It's not opening a dedicated socket, it's just pushing them through.
Yeah, I don't know the details of it, I must admit.
Thank you.
I don't know what the future will be, as I'm not on the standards bodies, so sorry, I don't know. I have no unique insight into that. So the question was whether Speedy will take over WebSockets, and I don't know. WebSockets is here now. Okay, so WebSocket browser support is now in most of the major browsers. So we have Chrome, Internet Explorer, Firefox, Opera, and Safari. And its benefits over long polling, etc., are, as we've discussed, really. So you get reduced latency in that there's no gap. The server can send the data as soon as it receives it. There's a large reduced network traffic. Because there's none of the HTTP negotiation overhead. There's just a sort of nominal framing in the protocol, so there's some bytes overhead for each message, but it's quite small. So this can massively reduce the CPU and memory on the server side. And actually, as we hopefully will see, it's quite simple to develop for. Okay, so WebSocket builds on top of HTTP. In the sense the initial connection is over an HTTP connection. So the client will basically send a GET request to a URL. It will also provide a host, so there's location-based security can be used. It will also provide a connection header which says upgrade. And it will then send 3 or more specific WebSocket headers. These are essentially, first one is the key, which is a hash of a certain GUID plus a nonce, and that gets sent over to the server. And then can say which protocol that the client wants to support, and these protocols are fairly opaque strings, although they can be registered. And it says what version of WebSockets it's using. And in response, the server must send back a 101 switching header. Say it's upgrading to WebSockets. It then also sends, actually there should be a carriage return there, a WebSocket accept, which is a hash of the nonce and a GUID, and says that which protocol it's going to support out of the 2 that was requested here. So that requested chat and super chat, and this server says it's going to use chat over the WebSocket. And these security headers, in quotes, are really a lightweight form of security, as these headers aren't available to JavaScript clients. So you can't set one of these headers in a JavaScript client as an XML HTTP request. So you try it to stop some sort of levels of spoofing. It's actually there for a complicated reason to stop proxy poisoning. But it doesn't prevent, obviously, a rogue client not written on JavaScript on a browser to send whatever it likes. Okay, so this is quoting from the RFC. So essentially, WebSocket is just a layer on top of TCP. It adds web-based origin security, so we send a location, and then the server can, that location will be sent by the browser, obviously, rather than the JavaScript, which is the location where the JavaScript was loaded from, and then the server can decide whether or not to accept. Adds the addressing protocol, which is obviously URIs, and the level of which protocols are supported. And then it has a lightweight framing on top of TCP, which is essentially splitting messages up into certain chunks and having certain frames of certain types, which we won't go into any detail, but it can do ping and pong for sort of lightweight keep alive. And it can have additional closing handshake, so the client can request a close. And it is designed to work in the presence of proxies. But it's not, at the moment, guaranteed that it will. It may or may not. The safest way to get it to work through a proxy is to do it over TLS. Because you can do WebSockets over TLS, and then proxy will... Obviously, the TLS is fairly opaque to the proxy. So the security channel tends to work much better than plain WebSockets. Okay, so the JavaScript API in... Oh, sorry.
So, in the previous slide, what does it mean when you say support multiple host names on one IP address?
In the same way that HTTP does. Because the initial opening is an HTTP GET, so it can have a host for that.
Oh, okay.
So you can use virtual hosting on top of it. Okay, so the WebSocket API is pretty simple in JavaScript. It's set in W3C standard. Oh, not quite yet, because HTML5 is not out. But essentially, there are a constructor for a WebSocket, which takes a location, which is obviously a URL, and a protocol, which is a string that you want to send to the server to say which protocol you'd like to use on the WebSocket's socket. There are then 4 callback functions that you attach onto the WebSocket object. So you have onMessage, which gets called when a message is received from the server. OnOpen, which is a callback when the socket's opened and negotiation has been completed. Close. Obviously, if you or the service decides to close the socket and negotiation of close is complete, then you get an on-close message. And then on error, if say there's a disconnect or something, the server goes away. And then you can 2 methods you can call from JavaScript, which is close, which is to shut down the WebSocket, and send, which is some data. And there's actually there's a couple of sends. One's for plain text, one's for byte arrays. So this is actually the W3C definition straight out of the spec. So there's a couple more attributes as well, which is ready state and buffered amount. And ready state just allows you to query what state the socket's in, whether it's connecting, open, or closed. It's not a huge amount of life cycle stages. So we'll quickly look into WebSockets in GlassFish. Any questions on that? We are getting to the code, honest. So just put some context. Okay, so this is what we're going to do is use GlassFish 3.1.2. So it is production quality GlassFish. It's using Grizzly 1.9, so it's quite old Grizzly, but the API in Grizzly hasn't changed drastically to the 2.x. But we're not going to use the JE 6.7 API. As GlassFish 4 was a little late for this, but this does work now in production. So the first thing you come across when you get GlassFish 3 is that you actually have to enable WebSocket support. So that will confuse the hell out of you if you go away and do these tutorials without doing that first, because none of it's going to work. And that is a long dot list of things, but that's where you need to set WebSocket enabled equals true. And you can go navigate down the admin console through server config, network config, blah, blah, blah. Okay, there's only 3 key classes that we'll see in Grizzly for WebSockets. There's a WebSocket engine, which is a singleton, a WebSocket application, which we'll see what we'll write, and then there's the WebSocket class itself, which you derive from, essentially, which we'll see, which implements your own protocol over the socket. Okay, so one of the key things about WebSockets is that it is your protocol. It is raw. It's not HTTP over this socket. You can send and receive whatever you and the server want to negotiate and send. So you could write JMS clients, you could write SMTP clients, whatever you like. You can send and receive any type of data. Okay, so I'll quickly walk through what I'm going to do so that you can keep track. So we're going to basically write a simple application that sends a message back that it receives from a browser. So we're going to, this is the Grizzly class, we're going to write an Echo servlet and an EchoApplication. And the Echo servlet is essentially going to create a new WebSocket application, which will be EchoApplication, which will extend WebSocket application. And in our init and destroy methods, we're essentially going to register our application with Grizzly's WebSocket engine. And then in Grizzly, the way it works is your application has to decide whether the request that Grizzly's received is one your application is interested in. Okay, so in this case, what we're going to do is check that the request URI ends with /echo. And then we return true to say that this is for us. So Grizzly essentially will iterate through every registered WebSocket application when it gets a WebSocket request. And it asks them whether they want to handle it, essentially. And then we will override on message in our Echo application, so basically to send back the string that we received. Okay, and then we'll put together a JSP, which will have 3 buttons on it: connect, send, and disconnect. Connect will create a WebSocket. Send will send some data. And on message, which is the callback from the API, that'll write the data that we got back to the screen. Okay. See if we can get it to work. So I'll basically create a new project. So it'll be a web application. We'll call it Echo Project for JE6 GlassFish server. Don't need any of those things. Okay, so I've got a new project. I'm going to keep track on my bit of paper. Otherwise I'll get lost. We'll add Grizzly libraries. This is only really for the IDE because they come with GlassFish anyway. Okay. So we now create a new servlet. Let's call it servlet. Let's give it a package because it's going to complain. Okay, and what the Echo servlet's going to do is we want it to register our Echo application, which we'll create in a second, when it starts. So we'll basically set this servlet to load on startup. So that way, so with that init will get called. Get rid of all this junk. And I'll go back and create an Echo application. So it's just a basic Java class. Am I in the right project? Hang on, get rid of that. Okay, and this is going to extend WebSocket application. And first thing we're going to do is we're going to override that is application request, which tells us, which basically Grizzly's going to call when it gets a WebSocket connection, and will ask us whether we want to handle that connection. So Where is it? I can't see it. Oh no. I've gone to my snippets now because I give up. I'm going to have to go back to the one that works because I can't remember why this isn't working. Okay, so that's what we want to override. Why it didn't let me do it, I don't know. Okay, so this is going to get called by Grizzly. So basically, we're checking the request URI and just see if it ends with echo. It's a bit of a hack, really, but that allows us to tell Grizzly that's a request we're interested in. And then we're going to basically override on message. So you can see there's actually two on message methods because from JavaScript you can either send a string or you can send bytes. So we're going to override the string on message. And in that we're basically going to send the text back. So what we'll do go back to our servlet, what we want to do is override init and destroy so that we can register that application with Grizzly. And as I can't remember it. Okay, so in the servlet initializer, because we've added load on startup, the servlet will get started as soon as it's deployed. And when it deploys, it will register the EchoApplication with the WebSocket engine of Grizzly. And then similarly, when we're destroyed, we want to unregister ourselves, otherwise bad things happen. As WebSocket engine's a singleton, it'll keep a handle on that application we just created. And it'll confuse you when you do redeploys, because the code won't change, because it's got the old application registered. Okay. So we'll now create a JSP. Called Echo. And this is going to do our WebSockets calls. So first thing I'm going to do is I'm actually going to create a div. This is going to be a div where we'll dump the output in the that we receive from the server using JavaScript. We're going to add 3 buttons, but I'm going to cut and paste these because it's quicker. So we'll create 3 buttons in our JSP. On click, which is going to call a function connect, which we haven't written yet. Do send, which is going to send a test message, and disconnect, which is going to disconnect. So we'll start writing those. it's not very good at Java. First thing I'm going to do is put some basically the WebSocket is going to want a URI. The URI is going to be built up in JavaScript from the location host that they received and page request and bit of the reason this is a JSP so we can get the page context that it's deployed to in GlassFish. That makes sense? So if we write the connect function here, which I will pinch again. So basically connect will take that URI. The URI starts with WS, which tells the GlassFish that this is a WebSockets connection. This is a JavaScript API. You create a new WebSocket, give it a connection. We don't have to give it a protocol if you don't want to. And then the WebSocket, these are the 4 callback functions. And we're going to associate these with some functions we haven't written yet, which will be on open, on close, on message, and on error. If we then write these next ones, so if we take do send, okay, we'll do disconnect first. So disconnect button will hook up to disconnect JavaScript function, and that's just going to call WebSocket close. And we'll try and write the do send function. Or I'll cut and paste the do send function. I can't write JavaScript to save my life, so this is why I'm doing this. I'm a server-side guy. So do send will take a message, which will be a test message, write to screen, which we haven't written, and it'll send it down the WebSocket. Okay? When we press the send button. Okay, and the write to screen function is obviously just a basic bit of JavaScript. It's going to use the div that we wrote at the beginning and just append to the inner HTML the message that we get from the server, or any message. So when we created the WebSocket, we gave it 4 callback functions. So these are on open, on close, on message, and on error. If I take the first 3, all these are going to do is write to the screen so that we can see when we get callbacks. Okay. And finally, if we look at our onMessage function, this is the message that the onMessage is the function that will get called when the WebSocket receives a message from the server. Okay, and we need to close our script. Any questions on that? Yep. Sorry? Yep. So the question is WS standardized? Yes, it's part of the RFC, the IETF RFC. Okay, any question? Yep.
Are there any protocol level delimiters? Because how does the server know that the TCP packets from the client, all the packets from the client is sent to survive?
Okay, what you send and receive is up to you in the sense of that level of protocol. There's a lower level framing which breaks whatever you send as JavaScript into a bunch of chunks, and the server then can reconstruct those into a single message.
So is there something called an end frame? Is there a begin frame or something like that?
Yeah, there's opcodes in it, so it's very lightweight. So.
Can I see the servlet integration?
Okay, again. So this is the servlet. It's got load on startup equals 1. The way it's interacting is it's only really a hook into GlassFish, essentially. So when it boots the servlet, then at that point it registers our WebSocket application with a Grizzly WebSocket engine. It's only there to give effectively a startup class. You don't need any of the other servlet servlet functions. You don't need to override process or do get or anything like that. In fact,
I guess you have to change the URL pattern. It's
as long as it doesn't match your WebSocket one, because that would be bad. But no, it doesn't really matter.
I mean, like from JSP, it's hitting the echo server.
Okay, no, it's not actually. So I'll go back to that. The JSP is not hitting the Echo servlet at all. The Echo servlet's only there to hook in the WebSocket application into the Grizzly engine. So if you look at the URI, it's going to call it's the host name / the web app context, but not the servlet / echo, and then EchoApplication. So as it's a WS, Grizzly will pick the WS and go through all the applications and ask them if they want to take this connection. And EchoApplication here checks that it's got / echo on the end and then says, yes, I'll take that
So that
request.
can be any URL that,
Yep.
Can you upgrade to WebSocket from HTTPS?
Yeah, you can do WSS as a URL, but it's not quite the same connection because you can do it over HTTPS because you can do the get over HTTPS, but when the browser comes back, it's obviously the JavaScript that's initiating the connection back, and you can use WSS and connect over TLS. So to do with SSL connection essentially. Okay, so we'll see if this actually works, which is the challenge. Okay, no one said I've written anything wrong yet, so.
But the only thing you said earlier in the presentation that with GlassFish 3 you had to enable the WebSocket. I didn't see where you did that when you brought it up.
Mine's already done.
Oh, okay. All right.
Yeah. Thought it might be a bit boring to navigate through. But yeah, you do have to do that, otherwise it won't work. Okay, so if we run this. Moment of truth. So GlassFish will boot. Maybe. So you can see it's 312. And it's Grizzly 1946. So it's not patched or anything. It's the Grizzly that comes with GlassFish 312. I don't want admin console. Oh no! Where the hello? Oh, it didn't take the hello world out. Okay. They must. It's not there. Okay, so we have our 3 buttons. If I hit connect, I bet nothing happens. Okay, we get connected, which is come back from the server on the on connect. If you go back to the JSP, our on open, callback was put connected, and then if I send, we get a response test message. All right, whoopie-doo. And that came from the on message there. Okay. So that it's, and if we disconnect, we get disconnected sent on our on close. And at that point, I can't send any more messages. Right, I can connect again and then send messages, get a response. Okay? Sorry, say that again?
So like at Chrome, you can see like what's happening in the covers in Chrome. Does it kind of show what's happening?
Ooh, don't know, never done it. Want me to try? Go off piste. Okay. Network. So it's sent a get. got one-on-one switching back. Oh, this is right off piece now. So, so if send, it's
It's not like capturing or recording.
because it'll be opaque to it, isn't it? Because it's a WebSocket socket.
Yeah, it's only capturing the HTTP set.
How about,
Oh, yeah.
Oh right, okay, sorry. Ooh. Does that do anything? Sorry? Do get? I can't see anything on the WebSockets thing. I have to click where?
to see the content of the transaction.
There. Where?
In the get,
In the get, there.
double click, alright? There you go.
Ah, okay. Right, okay. Oh, you learned something. That's why you come to Java 1. Okay, so if we do, that was the original one, I suppose. If we do disconnect, it's not updating. Maybe it's that one. It's that one. No, in that one. No, it's not telling me anything. Sort of works.
Maybe it just doesn't auto refresh. Like go away and come back.
Maybe, maybe.
So if you keep hitting connect, will it just keep?
Oh, if I keep hitting it, will it keep connecting back to the server? Don't know.
I'm new to this whole landscape of products. Is Grizzly just the product that manages the TCP connections? So that
Yeah, Grizzly's network layer inside GlassFish.
Okay.
So it's a network library.
My follow-on with her question is someone just kept hitting connect like a crazy person. Grizzly is smart enough to manage those repeated connections, I think.
I think so.
Either that or the socket is smart enough not to send it knowing it's already connected.
Maybe not. It's broken now.
The server's smart.
Yay. It's all gone horribly wrong. Okay. What I did want to do was refresh that. See, it's broken now. GlassFish is broken now. That's what happens if you hit send connect. I did say don't use it in production.
You need to now monitor your own state, trip a flag.
Well, I mean, you probably wouldn't have a button on there that said connect, would you? So.
If a person leaves the page, is it on active disconnect?
Yes. What I was going to show is if I take out GlassFish, that we should get disconnected. So. Okay, so that's it. Essentially, we've written our first WebSocket application. It is pretty trivial, to be fair, but don't let people hit connect all the time. So what I'm going to do is extend the application, I mean, in a very, very trivial way, as it's a 2-hour tutorial, to actually push data to the browser, as opposed to us. Because sending echo is not very interesting, because you can do that in HTTP, and with XML, HTTP. So what we're going to do is we're going to take this echo servlet and echo application, and I'm going to actually create a WebSocket. And if you notice the previous one, we didn't bother creating a derived WebSocket. We just let application handle with a raw WebSocket, the protocol. I'm not sure why Grizzly allows you to do that, but what we're going to do is create a derived WebSocket class called pushSocket, So if I take you through this again, okay, we've seen that. That's what echo. So we take the same echo server we had before, the same application, but instead of having our message on it, what we're going to do is create a WebSocket. When we get connect, we'll have override create WebSocket, and we're going to return one of our own derived classes for WebSocket. Next, called push socket. And what that class is going to do is it's going to override on close, so it gets the same callback methods essentially as on the client would get, on close, on connect. And during our connect, essentially you're just going to create a thread, which is obviously a bad thing to do. Don't do this for real. And in our thread, we're going to run and just send an integer down to the browser. Okay. And our JSP will be exactly the same as it was before, except I'll remove the send button. Okay, so let's see if that works. First, I will close all documents. I will start my GlassFish server, and I want to clean it before I do anything. So I'm going to undeploy the current app, otherwise bad things happen. Okay. So in the same project, what I will do is I will create a new class, which will be push socket. And this will extend, what will it extend? Why is that not working? Ah, that's why. I don't know the class name, sorry. It will just, so the class basically in the Grizzly package called default WebSocket, so that'll override a bunch of the standard callbacks to do nothing. So it's an adapter. I shall also make this in a really bad way implement runnable. I will override, first I will override on connect. So these are essentially all the callbacks that you get from the WebSocket spec. And that code is actually going to create a thread. So which again, not recommended, but it works for demo. I'm going to add a variable called run, which doesn't really work, but, and then I'm going to write the run method, but it's long, so. Okay, and so this is basically just going to be a really naff way of doing push. Okay, so this thread, when we create this socket, in the method of run method, so when we connect, we will create a new thread, and that thread is just going to go in an infinite loop and check whether if run variable down here is true and is still connected. And then sleep for 1,000, milliseconds, and then send. That send is the WebSocket send call. So it'll send toString of an integer down to the browser. We've got some logging. Okay, I shall also override on close or close. On close. Set run to false. Oh, didn't do that. So that hopefully would stop the thread.
Set your boolean to true.
Yeah, right, I do. That would have got me.
That would have stopped.
I thought I just did that. What's wrong? Right, and I need a constructor. Which I will steal from one that works. Okay, so have I got any errors there? Okay, so this is basically class extends from WebSocket, and this is where you can write your own protocol essentially between the browser and the and this class. So it has all. If I go back to this, well, I'm going to do this. You can see that the methods WebSocket has are the standard sort of methods that map to the WebSocket JavaScript calls. So you've got calls to onMessage, calls to ping. These are the data frames that get sent, and send. So you can basically, in this class is where you would generate your own protocol that you wanted to talk to the JavaScript client through. But in this case, it's not going to handle any messages from the JavaScript. Is just going to push periodically integers down the socket. Okay, so if I switch back to my EchoApplication, what I'm going to do is, as our socket's going to handle that, I'm going to override that. And then I'm going to basically override the default implementation of create WebSocket. And in this, I'm going to return our derived class of WebSocket. Okay. Sorry. Okay. Okay, so so all I've done now, that's all I need to do on that application. So what I've done is essentially created a new protocol, hooked it into the original EchoApplication class we had, so that when a WebSocket request comes in for this application, it creates a new handler essentially for the protocol called pushSocket and returns that back to Grizzly. And then that's all we need to do to hook it all up essentially. So if we go back to our original JSP. The only thing I really need to do, actually don't really need to do anything, but no, we'll just run it. Okay, so that's back to our original JSP. If I hit connect, hopefully, we'll see that now that's getting the numbers pushed down to it. So these are essentially, we're pushing integers down to the browser. Okay. So there's no messing around in comment libraries or anything like that. That's just straight, simple JavaScript, simple server-side programming. And actually the overhead of this is just a little bit of framing and an integer string going down that socket connection. I think my thread handling is really poor, actually, so disconnect doesn't actually work. You caught me out.
Because you block the connection method in the thread. You block the connection.
Yeah.
Maybe you change the run.
Yeah, I,
Run or start, maybe you can block it.
maybe. I was out there this morning trying to think, why doesn't it work that bit? But never mind. I didn't have time. You can see that GlassFish is spitting out that we're sending data, and this is incrementing. If I refresh, it will start from the beginning. Oh, no, it won't. Actually, I think it will. There we go. That's just GlassFish me complaining that I'm trying to write to WebSocket that's closed. Okay, so that's, very trivial, but that's hopefully trivial in showing you that you can actually write these things pretty easily. There's some, obviously, like any distributed computing, there's a lot of messing around on connect and reconnect and handling those sort of side of things. So what we're going to do for the final bit, and we'll probably finish early, so I apologize, is we're going to look at hooking this up to a data grid. So I'm going to do a little bit about data grids themselves. And this is where, sorry, question?
Quick question. When you say that the stack trace was due to Grizzly detecting that the socket was closed?
Yeah.
So who closed it?
Browser.
You refresh the page.
I refreshed
Oh,
the
you
page.
refreshed the page. Oh, okay, sorry.
So we got a legal state exception when I try to send data down the socket. What's it doing? What's it doing? Okay, so we're going to look at hooking this up. Did anyone go to the BOF Tuesday about data grids and things? Okay, so we're basically going to look at the code for that. And how that works, essentially. So most data grids essentially implement JCache. So we're talking about in-memory caching, essentially, distributed cache. So they implement JSR 107, which is coming in JE7. And essentially, we're going to use coherence, and that provides a map semantics for putting and getting data out of a distributed cache. Okay, so and the way these work is what we have is you have 4 JVMs. They have a cache within them. You put data in the cache, and the object is put somewhere else as a backup in another node. And these sort of technologies are of interest to the customers that we've been messing around with POCs for, because these are very fast. This is fast data, if you like, and fast in-memory data across many gigabytes. But if a node crashes, it's resilient because it will just creep another backup somewhere else. And this is just a little context. So a typical data grid that we'd be looking at, some of our customers is of this sort of size. So you're talking 21 node grid with around 4 gigabytes of heap in each one. If you add for duplicates, then you're talking about 42 gigs of data in memory is what they tend to look at. And this is can be finance, can be stocks, can be gaming information about who's on what gaming tables. But essentially, it's there in memory. But the bit that we're interested in is most of these products have an event subsystem. And the event subsystem is where you apply a cache listener onto the grid. That listener will be essentially interested in a subset of the data and whether it changes or not. Okay. So that when data enters the grid itself, the grid product, will tell the cache listener that something's happened. And that cache listener can then do whatever it wants to do, which in our case will be to send data down a WebSocket. Okay. So we're building this on coherence, but because I know it, and that's what a lot of the finance and gaming companies use. But coherence has a couple of classes has a map listener which receives map events. And essentially each time data changes, coherence raises a map event and calls your listener. And you override a couple of methods. So entry updated, we'll see this in the code. Entry inserted, and you do whatever you want to do when you receive those events. But the key thing is that these listeners can have filters associated with them. So if you're interested in a very small subset of the data that's in the grid, you can set a filter, and you'll only get events on that filter. So, for example, if a user connects and is interested in a certain number of stock symbols, then you can set a filter just for those symbols. And you'll only receive events on those symbols. And JSL 107 has a subset of this API to register cache entry listeners. And they're fired again on when it's expired from the cache, when it's removed, when it's updated, or when it's read. So what we're going to build, we've got rogue arrow there. So we're going to have GlassFish, and it's going to have an embedded coherence, simply because it's the simplest thing to do in a demo. And then we're going to run a command line application, and that's also going to be a full coherence grid member, just because it's the simplest thing to do in a demo. But we'll see in the next slide, it's not what you do in reality. And basically, this application, this stock ticker app, is going to place objects into the cache. Actually, it's just going to update one stock in the cache with a random number. And when that occurs, we'll have a cache listener on GlassFish. So an event will happen. That'll go to GlassFish. Oop. And then what we'll do in our event listeners, we'll push basically the stock price down through WebSockets to the browser. Okay. So in reality, the sort of architectures we're looking at in POCs is we have obviously something much bigger than that. We have a cluster of JE nodes, WebLogic, GlassFish, whatever. And then we typically would have a remote grid. And these remote grid would hold data that's of interest to the users on here. And obviously when these users browse the website, we set up, as we'll see in the code, cache listeners for the data that is of interest to them on that specific page. Okay? Then, as data gets put in from any other node, then events get fired to that cache listener that's been set up specific for that browser and for that user, and then those events will go down through WebSockets and push and update the browser's user interface.
What type of applications do you use to construct the data grid?
What?
The data grid, how is that constructed? What does that sit on?
In this demo, it's going to be Oracle Coherent. Is that what you mean?
Yeah, but I was just wondering if there's an open source equivalent.
There's Hazelcast or Infinispan, or they're the two main open source ones. And there's Gemfire, Gigaspaces, Streamscale. There's quite a lot. They're all very, very similar though, and they all tend to just, copy each other's features. So.
On the listeners, can those filters be fine-grained? I mean, is it just off of the key of the data, or can you set a filter where a piece of the data, not the key, but some, off of some other key?
It depends on the product. In Coherence, you can build up like a criteria API as a filter and push that, so it can be very fine-grained. Some of them it's just at the key level, so I'm interested in this key or this set of keys. But that is a product-specific thing. Okay, so this is the code we're going to write. Actually, a lot of this is going to be pre-built. I shall hook Coherence into it because you'll have seen the other bits. But essentially, we'll have a WebSocket engine. That's the Grizzly class. We'll create a stock servlet to initiate the stock application in its initializer. The stock application is going to create a stock socket when it gets a WebSocket connection. And that socket is going to establish a listener with a named cache, which is a Coherence class. Okay, and then we're going to have a separate piece of code, a command line Java app called stock ticker, which is going to update these stock objects in the named cache. And our stock servlet will receive those as in its events and will push the data down this WebSocket. Okay. So our stock is just going to be a POJO, implement serializable, so that we can serialize it around the grid. Our stock ticker, so this will be our Coherence client, our standard JVM, standalone Java command line process. This is all the code that will be in it. So it will ensure it joins a Coherence cluster. It will get a cache out of that Coherence cluster, and then in a loop, it will just take a stock object and put it into the grid with a key of C2B2, which is my company, and push the object in. Okay, so these three parameters are name, description, and price. Oh, sorry. So give it a random number for the price. So it's very volatile stock. Small cap. And then it's going to sleep for a random amount of time so that it doesn't look like we're just pulsing, doing long polling, basically.
It's all going to the same cache?
Yeah.
It looks like you're starting by some math.random.
No. The key is that. There's no sharding or anything. There's just one object with one key. Okay, and our stock servlet in its initializer is going to join Coherence, get the same cache, create a stock application, and register it into the Grizzly WebSocket engine. And our stock application is going to override create WebSocket to create a new stock socket, and all the way through this we'll push the cache, basically, object. That's the only change we're really going to do, is push the cache as a parameter. And in our stock socket, we're going to implement, it's not on there, never mind, we're going to implement a map listener interface for Coherence. And in our onConnect, so this is our standard WebSocket call, onConnect, we're going to add on to the Coherence cache a map listener, which is itself. Then entry updated is a Coherence call, which is a callback from Coherence when your entry that you're interested in is updated in the grid. And when we get one of these, we will call send update, and that send update will half the code's missing on here because it doesn't fit on the slide, but what it'll do is it'll take JSON, use Jackson, it comes with Grizzly, and change it into a JSON object, and then send it down the WebSocket as a string, JSON string. And then we're going to have a fancy JSP, which is going to use something called HighCharts, which is just a HTML5 graphing library. So it's all HTML5, so it's an HTML5 canvas. I don't think it's open source. I think it's free for non-commercial use. And in our JSP, on our onMessage function, what we're going to do is take the data we got from the server on a WebSocket, parse that back to an object from JSON, create an X on X-axis of a coordinate, which is going to be current time, and price, and that will let us, as we will see, graph price against time. And then on this high charts, we're going to basically add a point onto the chart series. Okay. If all that works, we have some lunch. Okay. So I shall clean up my GlassFish. I shall stop. I shall start it again. Okay, I've got one that I started already because there's too much code. But we'll add some in. So it's really the code you've seen before that I won't write again. So we have a stock class. This is the one. This is basically the data object that we're going to pass around. It's very simple POJO, serializable, 3 parameters: name, description, price, constructor with a bunch of getters on it, and a toString. Okay, it's pretty simple. If we go to our stock servlet, which we had before, again, it's going to be set up to load on startup. And in this case, we haven't hooked coherence in yet. So what it's going to do is, in its initializer, like before, create a stock application, which is a WebSocket derived application, register it into Grizzly, and then destroy, it'll unregister it from Grizzly. Same as before, same pattern. So in here, what we're going to do is add in coherence. So we're in the initializer, we're going to hook into the grid. Try and remember the code. So that gets us into coherence, that cache factory ensure cluster. I mean, I know this is coherence, but it doesn't really matter that much because the same products do the same thing. So we'll add a variable to hold our cache, which is a coherence named cache. It's just a coherence class. And then I can't remember the code. That's what it is. So from coherence, we'll get a named cache, which is called supporting odds for some legacy reasons from a different demo. Okay, and we'll store that in a variable. And in here, we will do shut down just to make sure we clean ourselves up when we undeployed. The other thing we will do is when we create an application, we'll basically pass through the cache as a constructor parameter. Okay, so if I go back to our application, yeah, there is, because I've added a parameter onto the stock application, so. And I haven't added it into the code here yet. So I'll do that. So I'm basically going to store the cache, essentially. just for lazy reasons. Okay, we're also, as before, in our create WebSocket, we created a stock socket. I'm also going to pass to that the cache object, just push it all through. I'm sure there'd be a better way, but the rest of it's the same as it was before. So we've got the same is application request where it checks for URI ends in stocks and decides that it will accept this URI as a application request for itself. Okay, and if we go back to now this. Why is that complaining? Shouldn't. Good. And again, in here we will add the cache as a parameter and an attribute. Okay. So this is a standard WebSocket. You're right, I do. Okay. And we're also basically what we're going to do is implement map listener. And implement those three. So basically these are the updates that you'll get called from coherence when things happen on the grid. So there's three methods in map listener, which are entry deleted, entry inserted, entry updated. Fairly simple. So we add those in. But otherwise it's the same code we had before in our other example. So on Connect, what we're going to do in Connect is add a map listener to coherence. So this is where we've got a new WebSocket connection coming in. So we need to say that we're interested in things happening on the grid. So we add a map listener. You can see that there's various versions. You've got one that takes filter, but we'll just basically listen to all events. And that map listener will be ourselves. There's this socket class itself. And then on close, we'll say we're no longer interested to. So we'll remove the map listener, which is us, from coherence, so that when the browser goes away, that we don't leave listeners hanging around. And then I'm going to pinch a bit of code here. So we can add a bit of code to the stock socket, which is essentially to send the update that it will receive down to the browser. So this code takes a stock object. It uses Jackson to basically take the object, write it into a string, okay, and then get the JSON string from there and send it down the WebSocket. So basically you can take that stock POJO, turn it into JSON using the Jackson libraries which come with Grizzly, and then send it through the WebSocket. And all we need to do now is, on these callbacks we get from coherence, which is entry deleted, which we'll don't really care about. For this, for entry inserted, entry updated, we will get from the event, we'll check that it is a stock, write some bad code. And we'll send then, and we'll send that down to our method we just written here. That does the JSON. And same for if we get entry update. So these are the coherence callback methods that get called when something goes into the grid. Okay? Anyone following? Okay. Not losing too many. I'm losing another one. And then finally, this is our command line app that we're going to write. Okay, at the moment it doesn't do anything with coherence. So this is just going to, it's got a main, it's just going to go in a loop, update a stock object with a random price. So we'll hook in coherence into this. Oh, I've forgotten the code. Yeah, it's a bit before that. That's what I need. Okay. So we get the same cache essentially. Okay. And then when we create this new stock with a new price, we will do cache.put, give it a key. Done. Okay. Then finally, we look at the JSP. So this has got the high charts in it, so there's a lot of JavaScript already in this project. But we look at high chart just for an example. Essentially, you create a chart object. We're not here to look at high chart specifically, but and it has a whole load of JSON properties you set for how it's going to render, what its title is, x-axis is a date time, and it's how often its ticks on the axis are, y-axis title, tooltips, and then a data series. Okay, and the first thing it's going to do is actually generate a bunch of zeros just so we have a graph to start with. But the interesting WebSocket stuff, so that's basically just setting up the high charts object within the page. So this is where we do our standard WebSockets we did before. So we have a URI as it was before. We create a WebSocket with that URI. We set on an on-open, on-close, on-error events, and in this case they do nothing. So we'll add a on-message event, which I can't. Sorry? You probably can, yeah. I haven't tried it. Get rid of that. So if we basically hook up the on-message, so the on-message function is going to take the string, it's going to parse it, the event data it gets, into an object. It's going to create a coordinate x, which is the current time, y, which is the price from the JSON object. Then it's going to add him onto this this chart as a point, and then magic happens. Okay, this might work. So if I run this JSP, hang on, I want to kill GlassFish first, if it's running. Just to make everything clean, because Otherwise, demo gods will kill me. Okay, so that's GlassFish up. So if I run this file that we've just written, if I run this file, oops. Okay, so it's deployed and it should at some point what we see is in the initializers called, coherence is booting up, and I'm waiting for Chrome to appear. Okay, so there we have, that's the high charts graph with the initial chart which had a load of zeros in it. Okay? So that's connected with a WebSocket. You can see here we've got WebSockets accepted by stock, and a WebSocket was called, but nothing happening yet. So what I'm going to do is run this Docticker application, and this is the bit that's going to push data into the grid. So just a Java command line app. So we'll see that kick off. It boots into coherence. As I'm not connected to the network, it's waiting on some network timeout. And it's not working. Damn it. Okay. So what I'm going to do is I'm going to stop that. Both. And I'm going to run one that does work. Right, so I will start GlassFish. It's not, what's GlassFish doing? Okay, it is this time. So this one should work. I did before. So again, it's booting coherence. And we'll run the command line app. Should have connected to the network. Hey?
Is there a way to make it not wait for that?
I'm sure there is, but there we go. So you see that this is the so that one there is the command line application. GlassFish is receiving the updates from Coherence as a event, and then this GlassFish is pushing the WebSocket the price down through JSON down the WebSocket, and that gives you. This here is all HTML5, so it's a canvas. It's not Flash or anything. It's got animation on it, but it's a nice library that gives you a nice demo. So, hey. There you go. We could probably do it in Firefox too. Yeah. There you go. Oh, sorry, missed. In the HTTP session, no, it can be, but not in this code. It's associated with the page, though. Yeah. It's just, each one's pushing. It's added a cache listener for each page, so each one's pushing the same data. But yeah, there's 3 sockets there.
If you want to push different data to different customers, how would be it?
That would just be a matter of setting up in this case, setting up the filter differently. When we create the WebSocket object, you would just set a different filter, and they would only receive those events.
So is it like tied to? I mean, can tie to the particular socket somehow, or?
Well, when we go in here, this object. So if we go back to the application, when this create WebSocket call gets called by Grizzly when there's a new client, so you create a new instance of the socket class, and that instance is, so there's one of these per WebSocket connection, so one per browser, which means that if you need to set up different data for that specific view, then you'd set it up in that class. Sorry, I can't hear. How did I boot it? How did I boot Coherence? Okay, it's in the servlet initializer here. Yes, that's the bit there. Ensure cluster basically says and goes away all the networking. It only comes back once Coherence has been booted and that you're in the cluster. That's when it starts spitting out all that stuff. Sorry? No, this is raw Coherence. It's not Coherence Web or anything like that. So this is just raw. Okay, any other questions? Yeah. Yes, can be. I'll put the slides in SlideShare and I'll put the code somewhere. I'll put it on our website somewhere. Okay, it's www.c2b2.co.uk. We had. Yeah, there is. Yeah, he came for the slides for me, so he's got the slides, but he won't have the code. So we'll probably put a blog about it and put the code on there. We actually have a blog doing a similar sort of thing with Infinispan, but it hasn't got a graph, but it has a whole bunch of odds updating through WebSockets, and that's on Tomcat, and all the code's on our blog as well for that. Because GlassFish, Tomcat, Jetty, they all support WebSockets at the moment. .co.uk. Yeah, UK company.
So, WebSockets is supported by IE 10.
Yes.
Is a little weird, yeah.
Yeah, I haven't got it here to test.
Supported in quotes. Is there any way of, like, do you foresee that there could be a way of having a plugin or some other way of enabling WebSockets as a user?
Okay, well, I mean,
Never be available to anybody, either
a lot of the commercial libraries that do this sort of thing, like Carsing and Push Technologies, they provide JavaScript libraries that do fallback. And they'll fall back either to long polling, Comet, Flash, which is another way that a lot of gaming companies now use Flash. They don't use long polling because Flash gives them a raw socket. But they want to get away from that because it's not very secure. So yeah, and some of the commercial libraries will fall back between those different techniques. So they'll use WebSockets first. If they can't do WebSockets, maybe Flash or Silverlight or something like that.
You would have to have different versions of your code base. Or
Yeah, that's why.
one of those fallback ones, right?
Yeah, that's why a lot of the commercial libraries will do that for you. So they'll do all that fallback transparently to you as a developer.
So you program it to all the fields.
Yeah, but they were all around before a lot of this stuff came out. So okay, so that's essentially it. So in summary, so WebSocket is effectively reducing latency because it is full duplex. So you can be sending data over that socket while your JavaScript's getting called back from what's coming back from the server. So there's no delay as there is in long polling or polling type model. The only data flowing is a bit of framing, which is a few bytes, and the actual raw data you send. So there's no HTTP overheads on this. There's only one socket, as opposed to, say, a Comet where you have to have two sockets, one to receive, one to send, and you have to do a whole load of code to work out, which message you received corresponds to which message you sent, because it's half duplex on HTTP. So it's much more scalable in that sense. You get one socket per browser or per connection. And stuff that we're working at the minute with customers is linking it into data grids to see if we can do enterprise scale push without having to go and buy a push technology or Carsing or something. So, and they're looking at this as POCs at the moment. The only barrier for them at the moment is browser support. So there's too many other browsers out there for them to do this in total for everybody. But they're looking at doing this because this works quite well on the modern mobile as well. So I haven't got internet here, but when we've done this in the past, we've put it up on Amazon and got everybody to look from their mobile devices and see which ones actually work, which is getting better. So. Yeah, exactly. Which ones can do render that picture, that graph, and which ones can't. The only thing about HTML5 at the minute we've seen is the actual CPU usage on these things is very, very high. So when we push prices much quicker to, say, a tablet or something, it just burns. And Firefox can burn like dual quad, just rendering a little graph like this. So JavaScript on the client can be a bit CPU intensive. But that's the same for any of these techniques, so, and HTML5. Okay. Thank you.